Behind me is a dual-deploy solid propellant rocket. In this lecture, I'll be covering concepts in electrical, chemical, and mechanical engineering. Now, have you ever wondered how a rocket actually gets off the pad? This is due to its propellant. Generally, there's 4 types: solid, liquid, gas, and hybrid. For now, we'll stick with the solid rocket, which is either epoxy-based, also called composite, or ammonium perchlorate-based. In this particular diagram, we have the propellant grains pictured here, and this is a delay grain. So this is the nozzle, and when your igniter goes into the top of the rocket, generally it's going to be here. So when your igniter goes off, it starts igniting this thing called a delay grain and your propellant. Now the delay grain is a timed burning between your burning of the fuel here and the time the black powder goes off and blows the parachute out of your rocket. So I guess we'd be looking at it like this, where this is down and this is up. So your igniter is burning, 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 and so is your delay at the same time. So if you have a 14-second delay and you have 8 seconds of burn time, that means you're gonna have 4 seconds of coasting while your rocket is still having momentum on its way up before that black powder is gonna burst your parachute out. What I find most interesting is the rocket's physical and chemical characteristics of the core. So once your igniter's in here and it starts burning this propellant, that relatively small diameter core in the rocket is going to expand, which is going to create more surface area for burning. And that results in different thrust curves. Now the reason these are all different is because these cores can be located in certain areas of the propellant, they can be different shapes, and that's going to result in these different kinds of thrust curves. Another thing to note is that these nozzles standard come plastic, whereas nozzles in NASA, you're going to see those being graphite and something that's more resistant to heat. But think about too, as the heat and pressure is coming out the back of that nozzle, the plastic is slowly disintegrating, and that is also creating a bigger diameter hole, which is allowing more pressure and energy to escape that, and that is losing pressure in your rocket. So it's pretty interesting to see that just the different kind of size nozzle and core and these little tiny variables can have such a big effect on the altitude and characteristics of your flight. Now we're looking at the guts of this operation, which is the electronics. You're going to want to use this in rockets that are reaching really high altitudes, where you'll use an altimeter that will sense the outside barometric pressure through pressure holes that you drill in the body of your rocket, which will ignite an igniter that you have wired through this part, through this hole, into your charge rails that are full of black powder. And there's 2 of them for redundancy. And you'll notice that I have one for drogue, one side, and the other for main. Looks like that's all I have time for today, but I hope you guys enjoyed and learned something cool.